Dear friends, today we will discuss the elementary ideas regarding the Deccan Trap. Coming to the first module, that is Introduction. The Deccan Traps are a large igneous province located on the Deccan Plateau of West Central India, that is between 17 degrees to 24 degrees north and 73 degrees to 74 degrees east, and one of the largest volcanic features on earth. They consist of multiple layers of solidified flood basalt that together are more than 2000 meter, that is 6562 feet thick, and cover an area of 500,000 square kilometers, that is 193,051 square miles, and a volume of 512,000 cubic kilometer, that is 123,000 cubic miles. The Deccan Traps began forming about 70 million years ago at the end of the Cretaceous period. The mighty Himalayas were just beginning to come up. The great dinosaurs that ruled the earth were disappearing, and the crust of the earth in the western India was fractured. This was a remarkable event, that is, large quantities of molten rock or lava were poured out from these fractures, filling up valleys and covering the hills. The eruption continued intermittently with the periods of quiescence, building up a huge volcanic province. The geological world identifies this volcanic province either as the Deccan Volcanic Province, or DVP for short, or simply Deccan Traps, and recognizes it as one of the largest igneous provinces, that is LIPs, representing high magmatic fluxes involving large amount of thermal energy in short period of geological time. The term Deccan Trap was coined by W.H. Sykes in 1833, and it is derived from a Sanskrit word Dakshin, meaning south or southern, and a Swedish word trap or trappa, meaning stair. The term was aimed to describe the step-like or terrace-like topography peculiar to this terrain. Deccan Trap magmas may have erupted through multiple centers, the most prominent of which may have been a shield volcano-like structure in the Western Ghats area. In this chapter, we focus on occurrence and distribution of Deccan Traps, lithology and structural features of intertrapian and infratrapian beds, along with lametta and bark beds have also been covered. The following modules will be discussed in this chapter: geology and general characteristics of Deccan Traps, lithology and distribution of Deccan Trap, structural features of beds in Deccan Trap. Geological background. The Deccan Traps province of India covers an area of 5 into 105 kilometers square. The basalt floors are generally 10 to 50 meters thick and tabular in form, dipping at less than 0 to 5 degrees in various directions. The thickness of the lava pile is more than 2000 meters in the Western Ghats area between Nasik and the southern edge of the Deccan Traps, and exceeds 1000 meters in parts of the eastern Deccan along the Tapti and Narmada grabens. In some southeastern and far northern regions distant from both the Western Ghats and the eastern Deccan areas, the thickness of the lava pile is less than 100 meters. In the Western Ghats and the eastern Deccan areas, a large number of dikes occur. In some cases, as dikes forms, these swarms probably formed under tensional stress fields associated with two main fault systems, the Panvel flexure and Tapti Narmada grabens. The lava pile in the Western Ghats is divided into 11 stratigraphic formations based on both field observations and geochemical characteristics. The uppermost Panhala formation appears on the southern edge of the Western Ghats, and the lowermost Jawahar formation exists in the Igatpuri section, indicating a southward dip of the formational boundaries. The main eruption of the Deccan basalts took place in a geologically short period of time, probably less than 1 million years, at 66 million years, indicating high eruption rate of 1 kilometer cube per annum. Probably the geological information such as the absence of thick intraflows sedimentary layers in any section and the lack of erosional profiles developed between successive eruptions also indicates a geologically short period of time for the main eruption. Plate tectonic reconstructions shows that the Deccan eruptions took place when the Indian continent passed over a plume situated beneath the present site of reunion. Coming to the general characteristics, number 1, eruption. The eruption of the volcanic materials was mostly through the fissures, and the Deccan traps are believed to be the result of the fissure type eruption at a few places like Girnar Hills, Ranpur, Dhank, etc. The eruptions were of the central type, showing differentiated rocks of various characters. Number 2, thickness. The Deccan Trap has the maximum thickness of about 3300 meters along the coast of the Mumbai, from where it decreases towards the east. It is about 800 meters in Kutch and 150 meters at Amarkantak and only 60 meters at the Belgaum. The individual lava flows on an average have a thickness of about 5 meters, occasionally reaching to 15 to 30 meters, and 29 such flows have been identified in a boring near Bhusawal. These are interbedded with sedimentary beds called as intertrapian beds. The lava beds show persistent horizontality with general dip, maximum dip being 5 to 15 degrees near Mumbai. Coming to number 3, that is aerial extent. The lava flows flooded several 100,000 kilometers of western, southern and central parts of the country, covering an area of 320,000 square kilometers. They occupy a large part of the Hyderabad, Bombay, Madhya Pradesh, Kutch, Kathiawar and Gujarat. Coming to number 4, that is the structure. The traps show well-developed columnar jointing caused by tensile stresses, the result of the contraction due to cooling. The columns are pretty long and polygonal in shape. The traps show a good deal of amygdaloidal structure. The step-like appearances of the outcrops and because of differential composition and weathering. Coming to number 5, that is composition of texture. The trap is essentially a basic rock of basaltic composition and is a dark colored or a melanocratic rock. There are very little signs of differentiation, but in some places like Pavagadh Hills of Gujarat and the Girnar Hills of Kathiawar, differentiated rocks are also observed. Coming to number 6, that is intertrapian beds. As the volcanic eruption was not continuous, a number of gaps are found in the lava flows. The successive lava flows are commonly separated from one another by sedimentary beds, which were formed under water containing valuable paleontological and paleobotanical data, throwing light on the history of periods of quiescence which intervened between the volcanic outbursts. Coming to number 7, that is the age of the Deccan traps. The enormous aerial extent and the thickness of Deccan traps and the presence of intertrapian beds in between the consecutive lava flows are sufficient to indicate that the formation as a whole has a considerable range in the geological time scale. Next is the age of the Deccan trap. The age of the Deccan Trap is fixed by number 1, the presence of fossils, chiefly plant found in the intertraps. Number 2, the age of the underlying beds called as the infratraps. Number 3, the age of the overlying beds. In the Narmada Valley, the traps are underlain by the bark beds of Upper Cretaceous age, possibly in a part equivalent to the Lamitas. Number 2, in Surat Baroch, there is said to be a distinct erosional unconformity between the top of the traps and the nummulitic strata for the basal Eocene contains materials derived from the denudation of the traps. Number 3, in Kutch, the traps overlie unconformably the Jurassic and Lower Cretaceous beds and are overlain by the nummulitis. Here also there seems to be an unconformity between the traps and the nummulitis, through this is not very clear. Number 4, in Sindh and in the Bor Hills near Ranikot, flows of the contemporaneous basalt have been described as occurring below and above the Cardita Beaumonti bed. This bed contains nautilus, some corals, echinoids and gastropods, which appear to indicate an Upper Cretaceous age. Work on the fish remains from the Lemmitas has shown that perhaps they are more allied to Eocene than to Cretaceous formations. The infratrapian beds exposed at different places have provided indirect evidences for assigning ages to the Deccan traps which lie above them. These beds at Dudukuru in western Godavari district have yielded several forms of gastropods, lamellibranchs and nautilus. The fauna from this locality has some affinities with the forms recorded from the Cretaceous successions of the Trichinopoly district. Some work has been done on the radioactive characters of the Deccan traps that seems to show that the traps range in age from Upper Cretaceous to perhaps as late as Oligocene. As the trap overlies the Bog and Lemeta beds, the eruption must have taken place subsequent to these formations, that is near about Cenomanian or the Upper Cretaceous period. The trap is overlain by the nummulitic limestone, indicating that the outflow of basalt ceased before the mid-Eocene period. Hence, the age of the traps lies between Upper Cretaceous and Lower Eocene periods. Number 8, stratigraphic classification. The Deccan trap formation has been classified into lower, middle and upper divisions by different workers. The lower traps, that is 150 meters, this is separated from the Lemeta and Bog beds through slightly unconformity. It occupies parts of the Madhya Pradesh, Narmada and Berar, etc. The lava have flue ash beds and show numerous fossiliferous intertrapian beds. Next, middle traps, that is 1200 meters. This is found in Malwa and central India. Here, lava and ash beds form thickest part of the series. It has no intertrapian fossiliferous beds. Next is the upper trap, that is 400 meters. This spreads over Maharashtra and Saurashtra. Here, lava flows has numerous ash beds and are interbedded with intertrapian sedimentary beds containing fossils, vertebrata and molluscan shells. Coming to the lithology, the Deccan Trap province, one of the most voluminous continental flood basalt provinces on earth, consists of basalt with a wide range of compositions, not only in isotopic ratios but also in major and trace element contents. During ascent of a plume-related magma through thick continental crust, the variety of compositions would be produced by various differentiation processes such as fractional crystallization, crustal contamination and accumulation of phenocryst phases. The range of the compositions could also be generated in part by addition of magmas derived from continental lithospheric mantle. The Ambani formation basalts, which form the thickest formations in the western Deccan, are regarded to be the least contaminated by continental crust and the least affected by continental mantle lithosphere. On the basis of neodymium, strontium, lead and oxygen isotopic signatures, the geochemical features of most other Deccan Trap basalts can be explained by mixing between the least contaminated Ambonale type magma and three types of materials: broadly granitic, possibly upper crust granulitic and amphibolitic. Probably lower crust and continental lithospheric mantle material The Deccan basalts are largely microporphyritic with phenocryst of plagioclase, subordinate augite and rare olivine. Phenocrysts are set in a ground mass consisting of plagioclase, augite, rare iron titanium oxide minerals and glass. Some basalts contain glomeroporphyritic aggregates of augite and plagioclase crystals, occasionally in association with olivine. In the Deccan Trap basalts, following main types occur. Number 1, compact and amygdaloidal basalts. The compact non-vesicular basalts with gas cavities filled with secondary minerals such as zeolites and chloropatite, which give them a spotted appearance. Both compact and amygdaloidal basalts often contain small slender laths as phenocryst, giving porphyritic varieties. Number 2, chloroapatic basalts in which a major portion of ground mass has been converted into chloropatite are common. When large amount of chloropatite are present, the rock becomes dark black. Number 3 is trachytes. Basalt in which practically no crystallization has taken place and which consists mostly of basalt glass is called as trachytes. They are very fine grained because of the low degree of crystallization and pitch black when fresh. Black trachytes on hydrothermal alteration acquire a vivid red color, and red trachytes are more common than the black variety. Both black and red trachytes disintegrate on exposure to atmosphere and fall to powder. The red powdery material commonly passing under the name of the red bowl is nothing but red trachyte, which has disintegrated on exposure to atmosphere. Within the Deccan Traps, at least 95% of the lavas are tholitic basalts. However, other rock types do occur, and they are alkali basalts, nephelinites, lamprophyres, carbonatites, etc. Basalt may be broadly classified on a chemical and petrographical basis into two main groups, the tholitic and the alkali basalts. Tholitic basaltic lavas are characterized by calcic plagioclase with augite, pigeonite or hypersthene and olivine rarely as the dominant mafic minerals. Basalt without olivine are also well represented. Next is the Deccan Trap distribution. In the western and central India, DVP or Deccan Volcanic Province is exposed mainly in the states of Maharashtra, Madhya Pradesh, Karnataka, Gujarat and Andhra Pradesh, and also has its nominal presence in southern parts of Uttar Pradesh and eastern parts of Rajasthan also. Based on the area of occurrence, the Deccan lavas have been further classified into 4 classes, with Malwa Trap occurring in the Malwa region of the Madhya Pradesh, Mandla Traps occurring in the Mandla region of the Madhya Pradesh, Saurashtra Trap occurring in Saurashtra region of Gujarat, and main Deccan Plateau occurring in states of Maharashtra, Karnataka and Andhra Pradesh. Today, the DVP occupies an area of about 500,000 square kilometers. However, original estimates of the extent of the lava pile prior to erosion and possible downthrow on the western side into the Arabian Sea are of the order of 1 to 1.5 million square kilometers. The lava pile has a maximum thickness of over 1.5 kilometers in the western part of the India, and it reduces to few tens of meters near exposed margins of the province. Kalsubai, a prominent peak in the western part of the Ahmednagar district bordering Thane district of the Maharashtra, is the tallest peak of the province, that is more than 1640 meters. Geologists believe that originally this area must have been much larger, probably twice as its present extent, and even extending over buried parts of the peninsula under the Arabian Sea. Coming to the economic importance, basalt of the Deccan Trap are used for the construction of roads and buildings. Quartz, agate, carnelians and amethysts, etc. Found in the almond-shaped cavities of the trap are used as semi-precious stones. Magnetite found in the beds of the rivers of this region supplies iron ore. The bauxite deposits are used in petrol refining. The decomposition of basalt yields argillaceous dark Aomi-regard soil, which is rich in calcium, magnesium, carbonates, potash, phosphates, and is utilized for the cultivation of cotton. In recent past, the blocks of the Deccan basalt and associated rocks have also been used by the European rulers to build majestic buildings like Gateway of India, Victoria Terminus, etc. Intertrapians and infratrapians. The Deccan Trap's associated sedimentary successions, that is infra and intratrapian, are equivalent the Lameta and Takli formation respectively of the peninsular India have a wide geographical distribution in central, western and central southern India. The intertrapian beds are a late Cretaceous geological formations in India. Indeterminate theropod and pterosaur remains have been recovered from the formation as well as dinosaur eggs. The mammal genera Decanoles, Sanitherium, Bharatherium and Kermerungulatum have been recovered from it as well. A number of sedimentary horizons are intimately associated with the DVP or Deccan Volcanic Province in the states of Andhra Pradesh, Maharashtra, Madhya Pradesh, Rajasthan, Gujarat and Karnataka. Based on whether they occur immediately below or are within the successive lava flows, these horizons are known as infra or intertrapians respectively. Although over 150 localities of infra and intertrapian beds are known, the restricted occurrence of these horizons near the fringes of the Deccan province is noteworthy. These sediments consist of sandstone, siltstone, shale, limestone and chert, and contain numerous plant and animal fossils. The dinosaurian remains are restricted to the infratrapian, where the intertrapian have first reliable record of angiosperms in them. The fossils yield Maastrichtian to Paleocene age. Historically, based on the presence or absence of the sedimentary horizons occurring within the lava pile intertrapian beds, the DVP was divided into three parts with upper, middle and lower. However, this scheme of classification is no longer vogue. Nowadays, the lava pile has been divided into a number of individual flows or flow groups, and their long distance correlation has been attempted at many places. This has been done using field expressions, chemical compositional variations as well as paleomagnetic signatures. The Deccan Traps are famous for the beds of fossils that have been found between layers of lava. Particularly well-known species includes the frog Oxyglossus pulseus, that is oven of the Eocene of India, and toothed frog Indobatrachus, an early lineage of modern frogs which is now placed in the Australian family Myobatracidae. The infratrapian and the intertrapian beds also contain fossils, freshwater mollusks. The sediments overlying the Precambrian basement and spanning Cenomanian to Coniacian stages of the Cretaceous represents a marine incursion from the west by an arm of the Indian Ocean. This marine incursion was the result of India's rift from Africa, and the marine successions is named as Bar group, that is Nimar sandstones, nodular limestones and coralline limestones. The lower part of Nimar sandstone is regarded as fluvial in origin and yielded some fragmentary sauropod dinosaur bones, whereas the upper part is brackish water for marine or to marine in nature, as evidenced by algae, bryozoans, bivalves, nanofossils, trace fossils and shark teeth. The nodular limestones and coralline limestones are essentially marine deposits seeding a variety of marine organisms such as mollusks, ammonoids, gastropods, oysters, echinoids, brachiopods, bryozoans, algae, trace fossils and shark remains. The late Cretaceous, that is Cenomanian to Coniacian marine sediments of central India, prevalently known as bark beds, have been deposited in the east-west extending Narmada Basin. As the epicontinental sea withdrew at the end of the Cretaceous, that is 66 million years ago, a new set of rocks representing continental sedimentation and designated as Lametta Formation were deposited over the bark beds. The Lametta Formation is a very important unit in the Cretaceous stratigraphy of India, as it yielded dinosaur skeletal remains, eggs and nesting sites over a wide stretch from Jabalpur in the east to Balasinore in the west. In fact, the earliest reports of the dinosaur remains from India came from the Lametta Formation of Jabalpur, that is Upper Narmada Valley, in 1828. The Lametta beds represent a mixture of nearshore marine, possibly lagoonal facies, and continental facies exposed in the Jabalpur region. However, the beds are mainly continental west and south of the Jabalpur. The environment of the Lametta dinosaur was quite similar to the semi-arid alluvial plain with undergoing activities of perogenesis. Dinosaur skeletons found in the Lametta beds were mostly fragmented or weathered and had undergone a significant amount of transportation by water. In recent years, many dinosaur eggs have been found in the Lametta beds. They are large and spherical, ranging from 14 to more than 25 centimeters in diameter. These have tentatively been assigned to Titanosaurus, the first dinosaur to be described from Asia. This genus has subsequently shown to be characteristic of southern hemisphere. The Deccan Traps is a huge igneous province situated in the Deccan Plateau in the west central India. It is one of the largest volcanic provinces in the world. The Deccan Traps are solidified flood basalts and consists of more than 6,500 feet of flat-lying basalt lava flow and covering an area of nearly 200,000 square miles. The Deccan Trap was formed 60 to 68 million years back at the end of Cretaceous period. The volcanic eruptions occurred at the Western Ghats some 66 million years ago. The release of volcanic gases during the formation of the traps contributed to global warming. The Deccan Traps region was reduced to its current size by erosion and continental drift. At least 95% of the lavas are thollitic, that is low potassic basalts within the Deccan Trap. The other rock types are alkali basalts, nephelinites, lamprophytes and carbonatites. It is assumed that the Deccan Trap's eruption was associated with a deep mantle plume. Thank you very much.